In this video, we're going to be taking a look at constructing a binary search. We're going to be writing the program in VB.NET 2019. And the whole reason for doing a binary search is so you don't have to do a linear search. So we're going to review a linear search, take a look at a binary search, see how it works, and then actually construct the program. So there are problems with linear searches. So linear searches are great if you have a small number of items. Searching a database for an item in a grocery store, though, that could take a lot of time. If a grocery store has 10,000 items and you're looking to see if an item exists in the array or database, it could take a very long time. Now, instead of trying to keep the amount of items in the array or the database very small, there's a better, more effective search you can use, and it's called a binary search. A binary search will continually check the middle of an item in an ordered search list and discards the half of the list which does not contain the search item. Now, you may be saying, I don't know what that means. That's why I'm watching a video. So here's what it means. So imagine we have a dictionary. It's impractical to go through every word in the dictionary in order, page by page, word by word, which is a linear search, until you find the word you're looking for. So imagine the word search. That's the word we're looking for. Here's how a binary search would work if we were going through the dictionary. The program will search the middle, approximately the middle, and find the word magnetic. The algorithm recognizes that the word search comes after magnetic, so it's going to discard all the words from magnetic down back to the beginning. So all the words starting with A all the way to magnetic, we've discarded. Now you're left with just half of the dictionary to sort through. It will then search halfway between magnetic and whatever the last word in the dictionary is. Imagine it finds the word styrofoam in the middle. Search comes before styrofoam, so it will discard styrofoam and all the words after styrofoam, and then it keeps repeating the process, searching the middle. So here's an example with the alphabet, something a little easier to see and illustrate. So it works the same way. So we're looking for the letter W. There are 26 letters. The 13th letter is M, and it looks to see if W or M is equal to W or W equals M, either way. And we know that W is not equal to M, but we know that W is greater than M. So what it's going to do is it's going to discard the letters A through M, and then we're going to be left with everything after M. So now our search goes from 26 items to this many items. So we go approximately in the middle and we check T. The program recognizes that T is not equal to W. The program also recognizes that T is greater than, or W is greater than T, so it's going to discard N through T. Now we're left with U, V, W, X, Y, Z. Approximately in the middle, it checks W is equal to W. Our search is done. So that's how a binary search works. If it was less than that, so let's say we were looking for P, we check to see if T is equal to P. It's not. So then what it would do is it would get rid of all these items and we'd be left with NOPQRS. So if the item we're looking for is greater, it's going to discard all the items before that. If it's less than, it's going to discard all the items after that. So let's go ahead and write a program in VB.NET so we can see this in action. Okay, so we've opened Visual Studio 2019. We are in console application working with the .NET framework. I've given myself some space here to work with. The first thing we need to do is declare some variables. So we're going to create a list of animals, and it's not going to be a very big array. It's just so we can see how this works. So we'll start with a list of 5. We are omitting index 0, so that's why it's a list of 5, not 6, because we are omitting index 0. And then we'll change it to 6 to make sure the binary search still works. So we're going to do dim found as Boolean because it's either going to be found or it's not. We're also going to do search failed as a Boolean because if the search is failed, we need to know and let the user know that it's not present in the array. So we're going to go ahead and set both of these equal to false. You could do that down in your submain, or you can do it right here. It doesn't matter what it's really whatever you prefer. We need to know the middle of the array. So we're going to set that as the integer. Well, how do we know what the middle is? Well, we also need first as integer, and we need last as integer. And what we can do is we can add the first and the last, divide by 2, and that will get us in the middle. And we also need to know is the item they are searching for. So those are the variables we need. And now we can go ahead and build our array. So what we're going to do is we're going to create a list of animals. We're going to jump to that right now, so you don't have to see me type it out. Okay, I have my array here. If you want to code this, you can pause the video and type these in. Of course, it's a very small list, but in our first index, we're going to have the word ostrich. In our second index, we're going to have monkey. In our third index, ant. Our fourth index, elephant. Our fifth index, bear. Now, you may be saying, well, in order for a binary search to work, it has to be in order. These are not in order. And of course not. And there's a simple way to fix that. Go back to the grocery store example. If we have 10,000 items and we need to insert a new item into, say, slot 500, I'm not going to reorganize everything from item 500 to 10,000. That would take way too long. There's actually a better insertion sort, which we'll talk about how to do a little later, but we're going to stick with the binary search for right now. So the way to sort that is array.sort. And then you open your parentheses and it wants to know, okay, what array do you want to sort? And we want to sort animals. And then what Visual Basic will do is it will do that for us. Now, what we want to do is we want to output our arrays so we can see it and make sure that the animal we're searching for, if it says it's found in index 3, that we know it's actually found in index 3. So what we're going to do is we're going to output our index. You do not have to do this, but the whole point of this video is to see how a binary search algorithm works. So what we're going to do is we're going to say slot and I is, and then we're going to do our animals I. And what that will do is it's going to output our animals. We're going to check it, make sure it works real quick. Slot 1 is ant, bear, elephant, monkey, ostrich. It's in order. It works. So we're good to go. We can actually code our binary search. So if you're following along, these the first letter is all capital because it's not really searching for the letters. It's searching based off the ASCII code value for each letter. So it's not really looking for the word. It's looking for the ASCII code value. It orders it based on the ASCII code value. For all intents and purposes, we don't really need to know that, but in case you're wondering how it actually works. So now we need to ask the user, what animal are you searching for? And then we simply record that. Now, if you're wondering how the for loop works, this video is about a binary search, not for how for loops work. So if you're wondering how for loops work, I strongly recommend you go back and check one of our videos on for loops. This is pretty advanced. This is not stuff you start doing on day one when you're learning programming. Found and search fields is already equal to false. We need to set first to 1 and last to 5. And what that's referring to, first is referring to the first item in the array. Last is referring to the last item in the array. Now, once it gets sorted, the last item in the array is going to be ostrich. The first item is going to be ant. So it'll rearrange these. And the whole reason we need to know first and last is so we can get the middle. So we're going to run a preconditional loop, and the reason we're running a preconditional loop is because we want to run it a minimum number of times. In a postconditional loop, the conditions are checked after the code executes. In a preconditional loop, the conditions are checked before the loop runs. So it's only going to run the minimum number of times. If you're not familiar with a pre and post conditional loop, I strongly recommend you check our videos on pre and post conditional loops. All right, so here is our condition. We're going to run this code while found is equal to false and search failed is equal to false. As long as both those conditions are met, this code will execute. So let's start with our code. So we need to find the middle, and we find the middle by doing first plus last, and we're going to divide it by 2. Once we divide by 2, we'll be in the middle. Now, there are some things that could happen once we search. So we need to check if the animals in slot 3, for instance, if that is equal to our search item. If it is, great. Then found equals true. The loop will exit and we'll say it's been found. But there's something else that could happen. Something else that could happen is where first is greater than or equal to last. And if that happens, then there's no more places to search, and our search has failed. But there's one more thing that could happen, actually two things, and that is where if the animal's middle, if it's greater than the search item, and that means like W is greater than T. So what we need to do is we need to update our first and last. So last equals middle, and we're going to subtract 1. We need to shorten it, and then if it's not greater than, it's actually less than. So then first equals middle plus 1. So that will be the code that will make it work. But now what we need to do is create some conditions to make sure it was found where it was supposed to be found, or that it was not found at all. So we're going to do if found equals true, then, and we're going to simply output a message, and we're going to say found in slot, and then middle, because middle is the one being updated. If it's not found, then we just write console.writeLine not present in the array. Okay, so that's going to be it. So let's go ahead and run this program, and let's make sure that it works. Okay, so we have our 5 indexes or 5 slots. What animal are you searching for? Now, because it's actually searching for the ASCII code value, I need to type them in exactly as I see. If I type in ostrich with a lowercase o, it's not going to find it because the ASCII code value is different. So let's start with ant. Ant should be found in slot 1. And it is found in slot 1. Let's run it again. Let's check bear. Should be found in slot 2. It was found in slot 2. What we need to do now is we need to check for the elephant. Elephant should be found in slot 3. It is. And then we need to check for the monkey. Monkey should be found in slot 4. And it is. What we need to do now is search for the ostrich. And that should be found in slot 5. It is. Now there's one more search we need to do. What we need to do is search for an item that doesn't exist, and it should not say found anywhere. It should say item is not present in the array. So we'll do a tiger, not present in the array. So that works. So now let's update our list. So let's say we have a new animal coming in, and let's say it's a tiger. We just go ahead and add the tiger to the array. This array.sort animals will take care of it. And there's something else we need to update. We need to update, first is still 1, but we need to update our last. Our last item isn't 5 anymore. It's now actually 6. And then we need to change the size of our array or we'll get an error. So 6. So that works out perfectly. So let's go ahead and let's search for tiger. We actually need to output the tiger. So we'll change this to 6. Okay. So now let's search for the tiger. It should say found in slot 6. It does. Let's go ahead and search for another animal to make sure it's still working. We'll do the elephant, found in slot 3. And then we have to do one more test looking for something that doesn't exist. A lion not present in the array. So that is how a binary search works. This is the code to execute that binary search. If you are in Cambridge Computer Science 9608 A-level, this is something you need to know. It's one of the algorithms that you need to know how to construct and run and understand what's happening. So I hope you found this video helpful. If you have any questions, post a comment below. We'll see you guys in the next algorithm video.